streaming to YouTube. Um, Learn to Code class. We're live on YouTube, and we are also sharing our screen on the Multiverse campus, and uh, maybe sharing our screen on the new test beta Multiverse campus as well. And my computer is loving the fact that I'm streaming from all these places. I'll tell you that much. So, uh, last Thursday goes full stack. Last Thursday goes full stack. It's going full stack, baby. What does that mean? So today's a little bit different, you know. I'm definitely taking my foot off of the pedal of like scaring everybody about the state of the world. We're not doing like our current events lecture. The app is a repo of repos. That's what we voted on. We want a place where we can easily index the projects that we've been working on in our Learn to Code classes. It's built, right? I deployed it through Vercel. There's a GitHub repo that's associated with it. We're gonna walk through all of this stuff together, right? I'm gonna stop at kind of the important parts. It's a guided tour of a building that is already standing, but it's like an empty office, right? So we're gonna look a little bit at the foundation, at the wiring, at the plumbing, and I think the importance of this for Learn to Code, like, and I would actually, you know, if you're working on your personal projects, if you like on the in the day to day you have like code that you're working, I would suggest getting into the habit of deploying test applications somewhat often, right? I think that it's important for coders, for developers to put their content into web applications that can be interacted with by other users through a link or however, right? Because there's this, we get caught up in this idea of Learn to Code being like, we're going to learn to write the Python syntax, right? And while we might do a little bit of that, in my experience, I spend way more time reading code and working in the sort of GUIs of these deployment apps and database applications than writing the code itself. And that time spent writing the code, especially with like the advent of AI, is just decreasing. You know, I spend way more time actually auditing code, understanding somebody else's code, understanding code that was written by the AI and refactoring it, than I do writing line by line by line, right? And that ability to understand, ability to read code, but not only do that, just like deploy, ship, execute programs. That's the actual skill that we're trying to fine tune. And it's worth practicing. So last Thursday, this application, this repo of repos, is becoming a real application, right? I've set up a GitHub login for it because it's a repo of repos. It's a repository of repositories. These are GitHub repositories. So I set up GitHub authentication. Users have CRUD access. They can add, edit, and delete projects. And then a little bit of user role permissions. There's moderators that can approve them. I deployed through Vercel just because it's a free option right now. And we have a Postgres serverless database situation because it's not going to be that large. It's just going to be the the repos that we've worked on. So there's not really much in the way of having to manage a server, right? And it's, you know, most importantly, there's no spend on that. There's no overhead on that. So a question for the class today. Feel free to answer on YouTube or the Multiverse campus, or even mic up if you want. Uh, do you have a GitHub account? Do you have a GitHub account? Somebody in the YouTube says, "Here we go, another reason for me not to pay attention at work." Yeah, yeah. Use me to distract you from your job. No, pay attention at work. Your attention is currency. Um, I just want to make sure people have GitHub accounts. If you don't have a GitHub account, we're not going to troubleshoot walking you through making a GitHub account, but make a GitHub account. Apply for a GitHub account, right? Uh, it's important, you know. Make your GitHub account. I would say it's you know, super important for this project. It's super important in your learn to code journey. It's a first step, and it's a great way to sort of like commit, no pun intended, to your coding journey. So set up a GitHub account. That's the first things first. All right. So static site to a full app. So yesterday, what we had was this kind of uh, it's a vibe coded static application, HTML file, CSS file, JavaScript file. The data is hard coded into it. So when I say hard coded, what I mean is there's no create, update, or even delete functionality for this. We literally write the code into the HTML or the JavaScript or the CSS for that matter. And all of this week 1 project, week 2 project, week 3 project, that is stored in the HTML file. Now, this is great if you're building like a single page application that doesn't need any sort of dynamic function to it. If you're building a portfolio page and you're going to be maintaining and editing the HTML file, if you're building some sort of splash page for a product or service that doesn't need much explanation besides just what's on the page and doesn't need like any sort of like user functionality, right? But you know, it's there, and it does the job of telling us what projects are what. The issue comes in when I need to add something or edit something. Where do I edit this code? Where do I, like, how do I edit this on the page? Like, how do I add a live demo here? How do I add a video to the project? I don't. I have to like literally go into the HTML file to make those changes, right? So yesterday what we built is kind of just like a visual demo. And if I wanted to add a project, I would have to open the projects.js, the actual like JavaScript file, type the data in by hand, and then redeploy. And so that isn't an application. This is not an application, right? This is a web page. This is a splash page. This is not an application, right? So what we've built today, and what I'm going to show you how to build today, is an actual application. So here we have the deployed Vercel app. You can see that I'm signed in with my GitHub account. It's the same idea. It's the same sort of theme, right? But now we have this ability to sign in. We have the ability to make new projects and add descriptions for them. We can open up other projects, edit them, delete them. Yeah, I'm logged in. My GitHub avatar is showing up there. That's me skydiving, which I really want to do again. Something about falling through the sky feels so good. And it's just like, yeah, so it's an application, right? GitHub avatar. Now I see the new project button. I'm authenticated. The app knows who I am, right? Yeah, no, highly suggest skydiving if you want to skydive. If you don't want to skydive, I also highly suggest it. Because now when I'm like having like panic attacks or just super stressed out about something that I have to do that I'm kind of scared about, I'm like, no, you jumped out of a plane strapped to a strange man from 15,000 feet up. You can do anything, right? It's good to kind of test yourself that way, as it is good to test the applications that you're building. Right? It's a segue, right? So sort of key concepts here that we'll be covering today with this full stack build. Authentication is going to be important for this application. You know, it's GitHub, it's connected to the GitHub repos, but we want to make sure we know who can add what, right? So you'll see that these are drafts right here, because I want to eventually add an approval process, a moderation process for the repos that we're adding to our last Thursday application. When I say CRUD, do we remember what that stands for? Does class remember what that stands for? CRUD, C-R-U-D. CRUD functionality is important to every website, right? It's create, read, update, delete. At the very least, a website should give the user access to the R part of CRUD, right? It's read access. What we had with that first example of the website that we finished yesterday, that was a read-only application, right? So that's CRUD. We're going to figure out kind of how to set up a simple database, a simple data flow, a simple data structure. Where does the data live, right? And then we'll touch on environment variables. How do we keep those secrets secret? We're working with Vercel now. We're working with GitHub authentication. Those come with client IDs that are public facing, and then secret keys that we should keep private. Otherwise, everybody now has access to authentication within our application. It's not a good thing. Or they have access to our Vercel database, right? So these are essentially the building blocks of every application, and every application that you're probably using, right? When you think about Instagram, when you think about Gmail, when you think about GitHub, same concepts of, you know, authorization, CRUD, database, environment variables, right? It's same concept structure, right? So what I kind of want to work into our heads right now is this idea that there is a difference between a web page and a web application. Does anyone want to take a stab at what they think the difference between a web page and a web application is?
Maybe a web app is a little bit more functioning like an app rather than like a web page. Like when you click on a link and it gives like a pop-out version of it that works a little bit different than like if you were to open it in an app. I would imagine it's something similar to that kind of difference.
Yeah, yeah. I think that gets close to it. You know, it's simple, right? Really, the difference between a web page and a web app is that a web page is going to show the same thing to everyone, right? So we set up a web page that's like a portfolio page or a splash page. It's the same information. What we're looking at right now with the with this presentation, that's a web page, right? Anyone who goes to this link will see this slide, right? A web application, you can do other functions with it. A web application will allow you to authorize yourself as a user. A web application knows who you are as a user and will show you different things based on that, right? So this is what authentication enables in our application. And authentication allows us also to store in users' local storage and in our own databases on a server. So it's important to keeping track of, like, once we're working with other users' data, or other users are relying on our application to create, update, or destroy their own data. It comes with just like a bunch of functionality that is really important for developers to understand. And this isn't the sort of code that you're going to be learning just by like running like Python practices in HackerRank, right? While it's important that you have an idea of how syntax works, I think it's more important in the moment to understand like how to deploy these applications, how authentication works, how to securely set up a database, how to securely store environment variables, right? So yeah, we were talking about skydiving, so I got distracted. But yeah, that was pretty much on it, James. Yeah, a web app is dedicated for this one page and purpose. Yeah, so web page is again something that isn't going to give us like access to our user content. It doesn't have any sort of dynamic content on it. A web app has dynamic content. Now I'm confusing myself with the word. A web page doesn't change. Everybody reads the same thing, right? A web app is gives us more of a dynamic experience, right? We are building applications in this class. We aren't. If we wanted to build web pages, this would just be like HTML, CSS, JavaScript class. The closest we've gotten to just building a web page is probably our TOS app. But at the end of the day, we wanted users to be able to rank TOSs and privacy policies on that. And that ranking ability, that ranking functionality, and that dynamic sort of functionality that we're looking for made it a web application, not a web page, right? So let's kind of simplify things a little, because now I think I'm just like confusing myself. So, I mean, I'm sorry about that. But there's 4 tools that are important in all of this, right? We have, and this is the entire stack that we're going to use for last Thursday, right? Next.js. This is what gives us the React application. This is what gives us built-in API routes. So what I mean when I say that, the React app, the API routes, right? The front end and the back end are living in the same project, right? This is our full stack development moment. Front end and back end are living in the same project. Auth.js that's going to handle our GitHub login, right? Uh, and then Vercel Postgres is our database. Vercel is what we are deploying out of, and it's gives us a database that's real SQL, real SQL that we're working with. And Vercel's also where we put our project together. We store our environment variables in Vercel. We also can store them locally. And Vercel is going to be where we deploy, right? So you might be asking, what is Next.js? Why Next.js, right? Next.js is a React framework. And yesterday we saw like you could build what we're building with plain HTML, CSS, JavaScript, right? We did that. We that was the static version. But the moment that you need a server, the moment that you need authentication, the moment that you need to run database queries, the moment that you need to keep secrets, right? You need something that can run code on a server. You're going to need this React framework or something like Next.js or something like Python, Django, right? Next.js gives you that without having to set up the backend separately, and it makes it so we can all we can containerize this project into one project instead of having a separate backend from front end. Auth.js is authentication framework, right? We're not going to build a login system from scratch. That would be like a week's project in and of itself, right? And if you want to build login systems, if that's like your true passion, cool. But I'm going to say that as a class, building a login system from scratch would be a bad idea. And that's not because it's hard. It's it's a little bit complex, but it's not that hard. But it's because there's like so many ways to get it wrong, right? Which is why you kind of like rely on pre-built frameworks for this, sort of the prefabbed auth.js, right? The millions of ways that you can get it wrong. Session hijacking, right? CSRF, token expiry. Auth.js handles all of that stuff, right? And so we can configure it, but we don't need to build it. And that's kind of like when we're doing full stack stuff, we need to sort of make these smart engineering decisions of like which frameworks are we going to employ and what are we going to build from scratch. And so sometimes it might feel like it's the lazy decision, but sometimes the lazy decision is the smart decision, right? So why Vercel Postgres, right? Why Vercel Postgres? We need somewhere to store our projects, right? You could use a JSON file. You could use Firebase, although I don't like Firebase. You could use MongoDB. We're using Postgres because it's real SQL, right? And it's a simple language that's, it's used by banks, it's used by hospitals, it's used by the government, right? So learning SQL, that's something that I feel like is important still, right? Learning SQL is never a waste of time, in my opinion, right? Like if everything were to shut down, there would still be SQL databases out there. I know, like I don't even like know how they like on a desert island you could access a SQL database. I don't know why this is. They're like it's like the cockroach of database languages. So Think of this sort of uh, I've used like this restaurant analogy before. Next.js is the building for the restaurant. Auth.js is like the security system, the lock on the door. Uh, and Postgres is the kitchen, right? It's where the food is being prepared, the data, right? And maybe Vercel is like the neighborhood where the our restaurant exists, so that people can find it. Simple restaurants, pizza places, right? We've used that before, but it's I don't know. It's a loose analogy. I'll get better as we go with these analogies. The project structure. All right. So um, the project is on my machine in VS Code right now. It's on a GitHub repo. If people want to check out the GitHub repo, I will link you to it. You said you had your GitHub accounts ready. Uh, so there you go. So GitHub link in there, GitHub link in there, GitHub link in there. Now there's like 9 places where I have to put GitHub links. And so the way that the project is laid out, everything is in the app folder. Or everything in the app folder becomes a route, right? So let's look at the GitHub. Let's pull this into here. And then let's just make it big. So everything in the app folder becomes a route, right? This layout page providers.tsx. Page.tsx, these are React TypeScript files, right? Page is the home page, right? So this sets up, we have it returning HTML, and this is the sort of TypeScript code that sets that up, right? We can dive into this code at another time. If you have any questions about it, throw it into the Learn to Code chat. This is like a pretty like high level overview of what we've built so far. But I want you to know where the code is and kind of know what it does. But I don't think we have time to go through it line by line. So the API folder. This is important, right? The API folder is where the server side code lives, right? So this is the code that never runs in the browser when your front end needs to create a project or check who's logged in. It makes a request to these API routes. So this is where we get like our routing function. This is our routing handlers. This is where we get some like next.js sort of boilerplate. Basically, we needed dynamic routing in our project. And what do I mean by that? When you have dynamic routing, you take things from being, these oversimplified pages like this to what we have right now, where it's when you click on a page, it pulls up a route that is project/3. So what that route functionally means is it's like the ID of the route is getting called through the project ID. It's a dynamic route. So if we look at um, if we look at page.tsx, we can see, where is it? Where we set up these IDs and we map them to each of the projects, right? So when we see ID in brackets get called, that is the dynamic route to that specific page. So I know it's a little bit like what. So in projects ID and then page, this is what sets up our dynamic routes. Um, and we could go line by line through this stuff and look at the code, but it's more important that you understand sort of the bigger structure here. Routing is important when you have a dynamic website, right? Why? Because you don't want to have to set up each page. Like if there gets to a point where there's 20 projects, 50 projects, 100 projects, there shouldn't have to be 100 HTML files, right? We should just be able to pull up the templates as sort of a boilerplate for how these projects look, um, and then render the right information through the database on the page. So I know it's like getting boring. I feel you. But here is our .env.local.example, right? The env does not live on the GitHub. Environment variables never get committed to GitHub, right? God dang, dude, I'm getting scam called today. So environment variables never live on the GitHub, right? So this .env.local.example, that file should give people that are working on the GitHub an idea of what the environment variable file should look like. So we have our GitHub ID, our GitHub secret. These are for the authentication, right? We have our next auth secret and our next auth URL. We generated our next auth secret using this OpenSSL rand base 32 command. So this is fun. If you are ever working on your own projects and you want to generate keys for yourself to use, instead of using just like passwords, you can run these commands. Oh, that needs to be a WSL. You can run a command like this in your console, and it will provide you with a usable code, right? So I use this like OpenSSL rand base 6432 to have this like key that is weird and hard to crack, right? And so and this is sort of just like a solid way to generate authentication, generate secrets for yourself, right? But let's and then there's the next auth URL, which is going to pull from a port and Vercel Postgres setup. So again, these are URLs to our database. These are sort of the secrets that our entire app needs to run. The file structure of our application is the architecture, right? It's how we're organizing the code and how our app works. If I look at this sort of file tree, or this file tree, what I'm getting here is, if I looked at a file tree like this, and I had never seen this project before, I should already be able to tell, oh, it has authentication, right? It has authentication set up. I should be able to tell as a coder, as a dev that's just hopping onto this project, that it has projects in it with some sort of CRUD functionality, right? Uh, and that it has a database. So when we set up our file structures of our personal projects, our projects that we're planning on bringing other people, friends, collaborators, coworkers in on, setting up a file structure that clearly lays out what the program does is important, right? And there are you can run tree commands from your console to get sort of this like tree layout of how your file hierarchy works. This is also something that you could have Claude or ChatGPT employ the AI to do for you, to give you like a file tree structured document. You can use a program called Mermaid to make diagrams of your file structure. You can use a program called OpenSpec, which will give you a nice looking file structure. Claude with OpenSpec and Mermaid works wonders. And you know, I think the real nugget of wisdom from using AI to help you set up these sort of clear file structure pages for you is you shouldn't, as a developer, be spending time formatting the like markdown of documentation for your application. You should be spending that time building the application, testing the application, using the application, right? Kind of eating your own dog food, so to speak, right? So, like, if we find ourselves like spending like days, weeks on our documentation, on our technical documentation, and we're not technical writers, like, you know, it's just not a solid use of time. But this project structure shows us what the project's about, and it's pretty straightforward. So cool. GitHub, OAuth, complicated. Something important to know. Authentication is super important. OAuth. What is OAuth? OAuth is sort of this dance between three parties, right? You have the user, you have the authentication application, and then you have the server, right? So in our example and in our program, we're using GitHub. In our application, we're using GitHub as the authentication service, right? You can use Google OAuth. You could use, I think Meta has a OAuth suite. Using sort of another party to handle the authentication helps to verify that authentication without building your sort of authentication from scratch, right? There's so many ways to authenticate users. It's important to think about the content that your website is working with when authenticating users, right? We are a repository of GitHub repos. We're going to use GitHub to authenticate our users. If you were building some sort of developer community or a community of people who code, who likely have GitHub accounts, and you want to encourage them to have GitHub accounts, you would use GitHub for that authentication. If you were setting up, you know, community of carpenters and contractors, probably using GitHub OAuth wouldn't make much sense in that situation. But you know what carpenters probably have? Gmail accounts, right? Google authentication would make sense in that situation, right? Or just your own custom authentication, right? So, but I've it's gotten to the point where I've noticed that general users, like uh, general internet users, web users, uh, get a little bit concerned when your site uses custom authentication. There is something to be said about the convenience and the comfortability that Google authentication provides to the user, right? I've before I have a website where before I had Google authentication set up on it, I had a few people just not make accounts because they weren't used to the registration login flow. And so, like uh, in one like at one end you kind of want to, you may want to be like radical or not have to use um, uh, Google or Amazon or whatever sort of oligopoly tech stack to make your product. But at the other end, you want people to have access to your thing. So I think sometimes you make those choices for the sake of accessibility. And then when it comes down to it, like so much is on AWS, so much is on Google already. No ethical consumption under capitalism, and that definitely extends to uh, web development. I'm not trying to be too depressive in that statement, but it's just how it goes. Um, so, OAuth, kind of this like handshake between three parties, a three-way handshake. User, GitHub, our server. User clicks sign in. They get sent to the GitHub website. GitHub asks, do you want to give last Thursday access to your profile? User says yes. GitHub sends a code back to our server on Vercel, and our server takes that code, exchanges it for a real access token, and then we have what's referred to as a session, right? That user is logged in. This is a web application. We are in the same session, right? Why is this better than passwords, right? Uh, you could come up with a bunch of different answers to that, but we never see the user's password. We never store the user's password. We're just accessing their GitHub account information, their avatar, their sort of role as it applies to these repositories. We never have to worry about somebody hacking our database and getting people's passwords because GitHub's handling our authentication. That's why it's better than passwords, right? We just get the result. The person's real. That's what we want to know. They have a username, they have an avatar, they have a GitHub. They're working on these repos, right? So the actual code here is route.ts. And look at how little code this is, right? It's not a huge amount of code. We're importing NextAuth, this Next.js authentication. We're importing the GitHub provider. We're configuring it with our client ID, our secret, and then we're exporting the handler, right? So this handler, we're setting up this handler constant, and then we're exporting the handler. That's the entire authentication system. That's what you get when you use GitHub or Google OAuth, right? Very simple sort of code. And then auth.js, the framework that we're using, is doing the rest of that for us. So when you build your own applications, if you wanted to use GitHub as the authentication provider, you open up your GitHub, you go to settings, you go to developer settings, OAuth applications, and that's where you would create the OAuth application. You give it a name, you give it a homepage URL, you give it a callback URL. GitHub gives you a client ID and a client secret, and those are what go into your environment variables. So that's the handshake that GitHub knows about our application, and then our app knows about GitHub. That's what we need to set up, right? Key concept here is that the environment variables are calling to GitHub ID, right? So let's see if I still have that open somewhere. Ba, 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 ba. And I know it's a little dense today, but as we start building these applications, that's kind of what it's going to look like. So whenever we call the GitHub ID environment variable, it will pull in process.env.github ID, process.env.github secret. Environment variables use this syntax. When we set up environment variables, we're pulling in those environment variables. So that sort of saying that GitHub ID equals our GitHub ID and GitHub secret equals our GitHub secret, that tells the rest of our application that when we say process.env.github ID, it's going to pull in the right environment variables. This is how every app handles, I mean, this is how most applications handle their secrets, right? So the database, right? A database is just your organized storage. It's a spreadsheet, a glorified spreadsheet, right? With rules attached to it, right? So each table is a sheet or a tab within your spreadsheet, right? And each row is a record. Each column is a field, right? So if you are the person that loves Excel and loves spreadsheets, that this might translate well for you. If you don't love spreadsheets, don't love Google Sheets, don't love Excel, you're gonna have to work with data at some point as a developer. So learn to love data. Data is awesome. Data is cool, right? The difference between a spreadsheet and a database is that the database enforces rules. You can make your Excel sheet, Google sheet do wonderful stuff, but in our database, right, the columns must be unique. Certain columns can't be empty. This row must reference a row in another table, right? These are rules that our database has, and we can set up for our database easier than if we were using a spreadsheet or a Google sheet, right? So we have two tables here. It's pretty simple database, right? Users is going to store everyone who logs in through GitHub, their username, their avatar URL, and then their role. So this role right now just defaults to user because we're not getting super into role permissions yet. That's probably going to be something that we dial in tomorrow. And then projects stores the project entries, right? So title, description, week number, author ID, and this links to users, right? So this is when it says FK to users, that means it's a foreign key to users, right? And it pulls the ID from the user, and so it will show the avatar URL there. And these IDs are primary keys, right? Serial PK, author ID, FK, right? So we have with this what's referred to as one-to-many relationship, where a single user can have many projects, but a project will be linked to one user as the author, right? So author ID in the projects table, foreign keys, right? This is an important thing to wrap our head around as we're learning to code. And apologies if this is like very beginner for some of you, or just kind of a little bit too intermediate for some of the beginners. We're trying to kind of like cast a wide net here. But the foreign key references the ID column in the users table, right? This is how we know who created the project. So if I look up project number 3 or project number 5, I can follow the author ID to find the user who made it. And this is relational data. This is what makes this a relational database. We have 2 tables that are linked now by this shared value of author ID. And that's why we're calling this a relational database, right? So in Vercel, you have a storage dashboard that has a section based off of the type of storage that you have. We are running a Postgres serverless section. So this is where our database lives. You can run SQL queries directly in the Vercel dashboard. And I am going to actually see if I can open this without showing too much of my my stuff here. Can I open the SQL? Postgres. All right, so it's what is referred to as a neon server. Oh, cool. Let's see if this works. Oops. Here is where I can just like type SQL into. So I will do this really simple SQL command, select star from users. This should select all of our users. And we see that it pulls back the users table for us, and it shows us one user, which is me. I have a GitHub ID of that, username vrnico, and my avatar URL of me skydiving, role, user created earlier this morning. So when you set up your own databases, you can play around with the SQL editor, and you can use the SQL editor to do some pretty cool analytical work on your application, right? Once you get users and data into your site, you can pretty much run any sort of like analytical referential work on your website using just the SQL editor. And when you start thinking about it in terms of like this glorified spreadsheet, right now with this select star from users, that SQL command could be the basis for a page that prints all of my users out to me. It's just the roster of my users. So you can look at websites and sort of think about like what SQL commands are being called here, you know? I mean, it's not always that they're running SQL commands. They're usually wrapped in some other functionality, but working in the SQL editor is of a site that you run with data that you're passionate about is a great way to get used to different SQL commands and just databases in general. Like honestly, like my homework for y'all would be like set up set up a database, deploy test websites, always be coding pretty much. So ooh, we're taking a lot of time with this. Oops, my bad. So yeah, we noticed the status column. Project start as a draft. They don't show up on the public site until a moderator changes them to publish. So this is a common pattern you're going to see. It's how WordPress works. It's how news sites work. It's how any sort of content management system works. So you've been using this pattern every time you read an article online. Now we know how it works underneath, right? So CRUD functionality, we're touching back on it. Create, read, update, delete. These are the 4 things that you do with data, right? Every app you've ever used is CRUD. Twitter, you create tweets, read tweets, edit tweets. Now we edit tweets. We weren't always able to do that. You delete tweets, right? Instagram, create posts, read posts, edit captions, delete posts. Email, create, read, update, delete, blah, 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 blah. It's all CRUD. It's all CRUD, right? So the post route, right? Line by line, first we get this server session. So this checks if a person making the request is logged in. If not, we're going to return a 401 error. Not logged in. This is authorization. You must be authenticated to create a project, right? The sequel of it all, right? Remember we did that select star from users? This is a SQL insert, right? Insert into projects. It's a SQL query that creates a new row in the projects table. So we take that title, we take that description, the week from the request body, we set the author to the logged in user, and we set the status to draft. The returning star at the end, I know this is like a lot of info, means give me back the row that we just created so we can send it to the client, right? So if we are to log in to our application and make a new project, we go to project/new, fill in the title, blah blah, fill in the description, and then we can watch. So this is running that insert query, right? Project appears in the database. We could go back to our Vercel Postgres dashboard and refresh it, and we should have our new project made, right? So in here, let's see, we'll go to SQL editor, select star from projects. Oh wow, these are so now we have blah blah this. It's there, right? So we have a clean sort of system set up here. It's we're making data, we're posting it to the internet, we're posting it to our Vercel storage. We're authenticating with GitHub. There's a lot going on with this. I know it's like it's cool though. It works for the most part. So roles and moderation are something that we'll get into more tomorrow. Just a string in a database column, right? It's not really this like magic sort of complex thing. So the user table has a role column. It defaults to user. If I go into the database and change somebody's role to moderator, they can now approve projects and edit anyone's work, right? So if I walk through these sort of permission functions, we can look at these. This person can edit a project. So if they're a moderator, they can approve a project, or if you're the author of a project, right? So this returns true if you're a moderator. These are called every time somebody tries to edit or approve something. If the check fails, the API will give a 403, which is forbidden, right? So a user creates a project, starts as a draft. It doesn't show up on the public site. A moderator logs it, sees the pending drafts in their dashboard, reviews them, and then clicks approve. I'm the only person on the website right now. You could go on the website. You won't see anything because my drafts haven't been approved yet. So the real question is, who should be a moderator for our site? How do we decide who gets that power? And this is like a real governance question, right? We're all working on these projects together, right? Every online community has governance, right? Discord has mods, Reddit has mods, our Multiverse school has, teachers and moderators, right? So subreddits have their own mods. Wikipedia has editors. This is a real question for the class and something we should meditate on today, like after class, is how we should handle our last Thursday moderation. And the bigger lesson here is that authorization is one of the most important concepts in software, in building communities with your software, right? Authentication is, who are you? Authorization is, what are you allowed to do? Every data breach you've ever heard of was an authorization failure at the end of the day, right? Somebody accessed data that they weren't supposed to access. So understanding this makes us better engineers for it, right? It makes us more critical users of technology. It's something that we need to know, right? So a little homework for today is like, think about who should be moderators for this site, right? And there's a couple right answers, a lot of wrong answers, but we can we'll figure it out together. This is the governance of this is whatever. Anyways, deploying stuff to Vercel. Now Vercel is watching our repo. So every time we push to GitHub, our Vercel, our like site will update through that Vercel link. So when you're building your own websites, you connect your GitHub repo. Make a Vercel account, you connect your GitHub repo. You set your environment variables in the Vercel dashboard. You push your code, Vercel automatically builds it, deploys it, gives you a URL. No server to configure, right? We don't have to mess around with Docker. We don't have to mess around with AWS's just god-awful console GUI situation as well. You just push it and it's live. Vercel's easy for that. It's a service for that. People pay for it, right? But there's also free hobby accounts for Vercel. Really easy to get up and running if you don't have much data or you have a small single page application. I suggest you just deploy something fun to Vercel sometime this week, right? Environment variables in Vercel. We put the same 4 environment variables that we showed in the environment variable example. Now they live in our Vercel, right? They're encrypted on Vercel's server. I'm not going to show them on the page because they're secret, right? So when our code runs process.env.github ID, it's pulling from Vercel's server. .github secret, it's pulling from Vercel's server. The code is running in the same place, whether it's locally or in production now, right? So only the environment is changing. And environment variables matter. Your code's public on GitHub. Anyone can read it. You don't want your environment variables on GitHub. I'm going to belabor this idea. It might seem like I'm beating a dead horse with this, but don't commit your environment variables to GitHub. The secrets, your GitHub OAuth credentials, your database connection string, maybe even your Vercel credentials, those are only on Vercel's servers. If somebody had access to your Vercel account, they will see those environment variables. If someone forks your repo and gets access to your Vercel account, that's your code, that's your application, right? So the idea is, when we build open source applications, we want it so that people can fork the repo, so people can look at the code, but they don't have access to the key, so they can't log in. They can't access the database. If they're working on our code, they're working on like kind of sanitized versions of the application. And separation of code and secrets, security 101. We could do an entire, month on cybersecurity. But yeah, so so commit push, it'll update on Vercel, and that's just proof that we're building right now. So it's Thursday tomorrow. We're putting out the last Thursday app on a Thursday. I know this class was like a lot of like worky, and not a lot of like thinky interactivity and taking opinions from the class. But in 1 hour, we pretty much walked through a full stack application. We have OAuth set up for it. We know what happens when we sign in with GitHub. We have SQL working on it. Now we know what a database table looks like. We have CRUD. We know the 4 operations behind every application, authorization. We know how roles and permission works. Environment variables, a huge one. We know how to keep secrets out of our code, right? And then deployment, how to get code from your computer to the internet. Vercel is cool for that, right? So full stack. It's not about just like being like, I'm full stack on my LinkedIn. It's a way to understand software, a way to understand coding. So when you use an app and something breaks, when you're full stack and you're thinking in the full stack sort of mindset, that means you can kind of guess what the problem is, where the problem is, right? Is it front end? Is it the API? Is it something with the deployment process? You can think through the whole system, work with the whole system, and that's what we're practicing today. We are all full stack developers, sorry to say it, right? So tomorrow, we're going to polish what we built. We're going to make sure everything works. We're going to have a place to finally put all of our repos. We're going to get organized. And if you want to create a project entry tonight, you have the link to the Vercel application. You have the link to the GitHub repo. Log in, add something. Maybe you'll get made into a moderator. By tomorrow, we're going to have real projects in the database on the real site. Let me know if you want to be a moderator on this thing. I'm definitely going to need like 2 or 3 volunteers. You'll be able to approve projects and keep this thing clean and maintain it. It's going to be a real responsibility, right? We keep on building applications with this class. So you're kind of deciding what that looks like. Breathe in, breathe out. We just read through a full stack application. We understand all the layers of it. It's a lot of content. 4 weeks ago, some of us hadn't even written a line of code, right? So now we know how login systems work. We know how to deploy. We know how APIs work, and that's not nothing. That is not a small feat, right? That's everything. That's a lot of it. It's a lot of the code. So I will see you all tomorrow. Links to the GitHub repo, links to the kind of demo working Vercel site will be up in the Matrix chat tomorrow at 10 a.m. I'll see you. I do have to hop off right now because I'm about to go into another meeting. But thank you all for coming, and